Alright, so I am starting this video and we are doing graphing rationals. I'm going to work through two examples where I kind of talk through the process of what I'm doing as well as showing you what I'm doing, so hopefully we can connect some of those gaps. So the first thing we always want to do with these is decide if we are in transformation form or if we're in general form. The easiest way to tell is that you're going to have an x in the top and the bottom for general. If you have that, you cannot use your transformation rules. There are a couple of exceptions to that, but that's what you're going to see mainly here. So the first thing I'm actually going to do here is find my horizontal asymptote. And in order to find the horizontal asymptote, we're going to compare the biggest degree in the numerator and the biggest degree in the denominator. So when I look at the numerator, which is the very top, the highest degree or the biggest exponent I have is 2. So I'm going to go ahead and write that in for numerator. And I'm going to look at the very bottom too. I have x squared minus x minus 12. And the biggest degree I have there, or the biggest exponent, is also 2. Now there's three situations. You can have your numerator is less than your denominator, your numerator is equal to, or greater than your denominator. So when I compare 2 to 2, I notice that 2 equals 2, so my numerator is equal to my denominator. When that happens, we're going to take those two highest degrees with their coefficients. So on the top, I have x squared over x squared. I'm looking at those coefficients in front, and if you notice, there's nothing on both, so you need to remember that there's a 1. When I go and I turn this into a fraction, I have 1 over 1, and 1 divided by 1 just reduces to 1. So my horizontal asymptote is actually at y equals 1. Now, I've already done the horizontal asymptote, so I'm now going to focus on the vertical asymptote and the wholes of this equation. Now, in order to do that, we need to factor the top and the bottom. So on the top, I want to think about factors of 12 that add up to give me positive 7. So I have 1 and 12, 2 and 6, and 3 and 4. Now, if you notice, I need them to add up to this positive 7x in the middle, so we're actually going to use that 3 and 4. So what the top now factors into is x plus 3 because the 3 was positive, and x plus 4 because the 4 was positive. I'm going to do the same exact process for the bottom, but now I have a negative 12 to think about. I still have the same factors, 1 and 12, 2 and 6, and 3 and 4. This time, since I multiply to get a negative number, one of them is going to have to be negative, but I want them to add up to a negative 1. So in order to do that, I'm going to do a negative with the 4, and I find out that 3 and negative 4 are the factors I'll use. So to factor the very bottom, I still have x plus 3 because that 3 is positive, but now I have an x minus 4 because this 4 has a negative with it. So what I have now is this x plus 3 times x plus 4 on top, and x plus 3 times x minus 4 on bottom. I want to see if I see something in the top and the bottom exactly that I can cancel out, and I do. I have x plus 3 in the top and x plus 3 in the bottom. When I cancel that out, I'm left with x plus 4 over x minus 4. This is your simplified or your reduced rational, which you'll be using from here on out. Since I had something that canceled in the top and the bottom, that automatically tells me that I have a hole in this graph. I take whatever canceled, so it was x plus 3. I set it equal to 0, and now I'm going to solve. When I solve, I get x equals negative 3, so I know that there's a hole at x equals negative 3. To find my vertical asymptote, though, I take whatever is left in the denominator or the bottom of the fraction. So in this case, it's x minus 4. I set that equal to 0, and I solve that, and I find out that my vertical asymptote is at x equals 4. The next thing we are going to talk about are the intercepts. So I'm going to rewrite my reduced one here. So I have f of x equals x plus 4 over x minus 4. So once you reduce, that's the rational that you're using. I'm going to go ahead and deal with the x-intercept, which tells me I'm going to take that the numerator, x plus 4, and set it equal to 0. When I solve for that, I get x equals negative 4. And since it is an intercept, it's a point, I'm going to write it as a point of negative 4, 0. Very similar, I'm going to do the y-intercept, but for the y-intercept, we're actually going to plug in 0 for x. So I have 0 plus 4 over 0 minus 4, which brings me to 4 over negative 4, and finally negative 1. If I wanted to write that as a point, I plugged in 0 for x, and I got negative 1 for y. I do kind of want to run through this video and show you the RAIN process where those steps are if you're confused. So in the RAIN process, you actually do not do the horizontal asymptote first. You reduce first. You do the factoring first and you get your reduced radical. Then you deal with your asymptotes, so your horizontal, the whole, and the vertical asymptote. You then talk about and find your intercepts. And the last thing you would do is the in or the number line analysis. For the sake of this video and for the sake of time that we have for this test, if you can't do the number line analysis, do not worry about it. As long as you have the other information, you should be able to graph correctly. So I am going to list out all the information we have so you can see how it works together. I'm going to list out my horizontal asymptote and my vertical asymptote. I'm also going to list out that hole that I found, the x-intercept, and finally the y-intercept. So I know my y-intercept, I found it to be 0, -1. My x-intercept was -4, 0. My vertical asymptote was x equals 4. The hole was at x equals -3. And the horizontal asymptote was at y equals 0. Now we just found all of that, but I want it closer for when we graph. The first thing you are always going to graph are your asymptotes. So I'm going to go ahead and graph that horizontal asymptote at y equals 1. So it is right here along and it hits that y-axis. I have my vertical asymptote of x equals 4. So that ends up being here as well. Now I'm going to go ahead and graph the intercepts. So you do your asymptotes first, then you do your intercepts. My first intercept is at 0, -1. That is your y-intercept. The other one is at -4, 0, which would be over here, and that's your x-intercept. Once you have your asymptotes and your intercepts plotted, you're going to go ahead and sketch those curves. So this kind of tells me I have my curve go down, and then it comes up and gets really, really close to that asymptote. Since I have one down here, your curves are actually diagonal from each other, which tells me I'm going to have one in the top right as well. The very last thing you are going to draw is that hole. So it says there's a hole at x equals -3. So all I'm going to do is come over to -3, and whatever curve is there, I'm going to draw a big open circle representing that hole. Now this was just one example of graphing rationals. I am going to do a second one to show another situation as well. Alright, so the second example we're going to do is x plus 4 over x squared plus 6x plus 8. The process stays the exact same. There's just one situation that really changes here, and that's the horizontal asymptote. So the first thing I'm going to do is that horizontal asymptote. Again, I'm going to compare the numerator degree to the denominator, and when I say the degree, I'm talking about the highest exponent. So in the very top, the highest exponent I have is just x to the first, so that exponent numerator is 1. On the bottom, I have x squared, so that exponent is 2. When I compare 1 to 2, I know 1 is less than 2. So in this situation, my numerator is less than my denominator. If you have the situation happen, your horizontal asymptote is automatically y equals 0. You just have to memorize that. You don't do anything else with it. Now, just like the last example, I'm going to start on the reducing or the simplifying, which means I need to factor the top and the bottom. But there is nothing to factor in the top, so it's going to stay x plus 4. Over the bottom, I need factors of 8 that add up to 6. So I'm going to end up with x plus 2 over or times x plus 4. I want to see if there's anything in the top and the bottom that repeat exactly, and there's x plus 4. Now, when you have everything cancel out in the top or the bottom technically, you have a 1 left. So I have 1 over, and then whatever's left in the denominator is x plus 2, and that goes down with it as well. Because I had something cancel out, that tells me that we have a hole. So that I take that, x plus 4, set it equal to 0. And when I solve that, I see that this graph has a hole at x equals -4. The next thing we're going to do is we're going to deal with that vertical asymptote. I take whatever is left in the bottom or the denominator, x plus 2, I set it equal to 0. When I solve this, I get x equals -2. So I've now found my vertical asymptote, and it's at x equals -2. Just like last time, I'm going to rewrite that reduced rational that we have because I'm now going to find the intercepts. My x-intercept, remember, we take the numerator or the very top of the fraction, set it equal to 0. In this situation, though, I have 1 equals 0. This is not a true statement, so there is not an x-intercept. For my y-intercept, I'm going to take 0, plug it in for x. So I have 1 over 0 plus 2, which turns into 1/2. Again, we need to write it as a point. We plugged in 0 for x, and I got 1/2 for y. If you're using the RAIN process, the last thing you would do is the number line analysis. I'm skipping that here just for the sake of time. And so we are going to go ahead and start graphing. Before we graph, though, we are going to list out all the pieces and components we have. For my y-intercept, I have 0, 1/2. My x-intercept, I don't have one, so it's none. There is a hole at x equals -4. My vertical asymptote is x equals -2. And my horizontal asymptote is y equals 0. Now I'm going to go ahead and start graphing. So I'm going to draw my graph over to the side. And I'm just going to start graphing piece by piece. So my horizontal asymptote is at y equals 0. What that means is that it's actually along the x-axis. So I'm doing this in red just so you can see for graphing purposes. The next thing is the vertical asymptote, which is at x equals -2. So that is here. We've got those asymptotes graphed. So now we're going to graph the intercepts. There is not an x-intercept, and that's because there's an asymptote of the x-axis. So there's no way there could be one. The y-intercept is at 0, 1/2, so somewhere like here. And now we can sketch our curves. I know there's one in the top right because of that intercept. And since they're diagonal from each other, I know there's one in the bottom left. I also know that there is a hole at x equals -4. So I'm going to come over to where x is -4. I'm going to go down on my graph, and it's about right there. Remember, the hole on your graph does not have to be exactly where it should be. So these were just 2 examples that I wanted to work out so you could see the process. Remember, if you can get parts of this, you'll still get partial credit for it. And if you have to skip the number line, please do so it doesn't mess you up.